So in this segment I'm going to discuss how you would solve hybrid problems involving addition and subtraction and multiplication and division of physical quantities that are not known more precisely than, say, a few significant figures or a few decimal places or a certain level of placeholder. So here's an example of a hybrid problem. 26.17 divided by the quantity 31.2 plus 3.7644. In other words, we're assuming that these are physical quantities and none of these numbers was an intrinsic part of an equation. So here's our plan. What we're going to do is we're going to solve the addition problem in the denominator, just as we would if this was just an elementary math problem. But we would keep in mind that the actual precision of this answer is only good to the tenths place because of the 31.2. And again, it has nothing to do with significant figures. If this was a 9.2, it would still be good to the tenths place, even though the resulting tenths place of that addition problem would give 3 sig figs and 9.2 has 2 sig figs. No, it's not about sig figs. It's about the fact that the 31.2 is good to the tenths place. But the result of that will mean that this answer, even though the calculator will give us a different number, is only good to the tenths place. And the tenths place of this result, you can run it in your head, it's 34.9644. That's also only good to the tenths place. And what is the tenths place of 34.9644? That is the third significant figure, which means that this number would only be good to 3 significant figures. So what do you have after that? You would have a number with 4 significant figures divided by a number with 3 significant figures, which means that your answer will be good to 3 significant figures after you run all this through. Again, it has nothing to do with the fact that 31.2 has 3. Even if this was a 9.2, our answer would still be good to 3 significant figures, it turns out. So let's see how it goes. So again, the 31.2 is good to the tenths place, so the denominator of this fraction, which was the result of a sum, remember with addition and subtraction problems, it's about the placeholder, the least precise placeholder, so this sum is only good to the tenths place. But now you're about to do a division problem, and remember with multiplication division problems, it is about significant figures. So the question is, the tenths place on this is what significant figure? It is 1, 2, third significant figure. So we have 4 sig figs over 3 sig figs. So this number needs to be rounded to the third significant figure, or the nearest thousandth, which is 0.748. So next, let's look at a practice question of the day with a hybrid problem. And so here's how it would go. You have a 45.642 plus quantity 16.4 over 9.13 minus 1.0624. So here's how your work would go. You'd say, okay, you would have a 45.642 plus, in other words, you would rewrite what you are originally given, and then at each stage you do a calculation. So first we need to reduce this denominator, 9.13 minus 1.0624. Well, 9.13 is only good to the hundredths place. So this number right here is really only good to the hundredths place. Again, don't round early. You can't round this to 8.07. That'll give you a wrong result potentially in the end. But keep in mind that this is good to the hundredths place. Now you're about to do a division problem. You have a number with 3 sig figs divided by another number with 3 sig figs, which means this answer right here has 3 sig figs. Well, what is 3 sig figs here? 3 sig figs is, as it turns out, 1, 2, 3. It's the hundredths place. So this number right here is good to the thousandths place plus a number that's good to the hundredths place. So the overall result is good to the hundredths place. Now, in terms of showing your work, you would need to show the result of this calculation in the denominator. You would need to show the result of this division problem, and you would kind of, again, you wouldn't need to write it down necessarily, but I kind of recommend maybe putting a dash or an underline or something like that to remind you that this is the third significant figure is the hundredths place, so this is good to the hundredths place for this next addition problem. And you should show the result of the addition problem as well as the final answer. And generally, it's a good idea to put a box around the final answer. Now, in general, you should always show all of your work for the solution to a problem in this class. It gives you good practice for preparing for the AP exam, where they're generally expecting to see your work, and it's something that I require. I grade you based on the work that you show. So you should make sure that you show all of your work. If you were to have a complex physics problem and you only wrote the answer and saying, oh, I did all the work in my calculator, well, if it was on a test and if it was worth 10 points, I might give you 1 or 2 points out of the 10, but you would be missing all of the other points for writing your givens, showing the equation, showing the process, and everything else. So make sure that you show all of your work. And in general, it's a good idea to put a box around your answer. Also, when you do plug in givens into a formula, make sure that you include the units for two reasons. One, it shows that you really know what you're doing. Two, it shows that when you have your units canceling and working out, that it's going to give you confidence that your answer is actually reasonable. If units don't cancel the right way, or if you end up getting wrong units in the end, that's an indication that you either remembered the formula incorrectly, or you made a math mistake, or maybe a combination thereof. So make sure that you show all of your work.